How do you use the if-else statement in Verilog? If you are curious about how to use the if-else statement in Verilog, you are in the right spot. This control structure is essential for making decisions in hardware description. It allows you to specify different blocks of code that execute based on whether a condition is true or false. This concept is similar to how if-else works in programming languages like C, but in Verilog, it describes hardware behavior. At its core, the if-else statement evaluates a condition. If the condition is true, the code inside the if block runs. If the condition is false, the code inside the else block runs. You can also chain multiple conditions using else if for more complex decision-making. The basic syntax looks like this. If condition begin. Code to execute if condition is true. And else if another condition begin. Code to execute if another condition is true. And else begin. Code to execute if no conditions are true. And you can use as many else if branches as you need. The begin and end keywords group multiple statements within a block. In Verilog, if-else statements are usually written inside always blocks. These blocks model sequential or combinational logic. For combinational logic, include all relevant inputs in the sensitivity list of the always block. This ensures the logic updates whenever any input changes. For sequential logic, such as flip-flops, the always block is sensitive to clock edges. A common practical use of if-else in Verilog is to describe multiplexers. These components select one of several inputs based on a control signal. For example, a simple 2-to-1 multiplexer can be written like this. Always at cell or B begin. If cell is equal to 1. F is equal to A. Else, F is equal to B. And, in this case, the output F gets the value of if cell is 1. Otherwise, it takes the value of B. Another typical application is in sequential circuits like registers or counters. Here, the if-else statement can control reset behavior or increment logic. For instance, a D flip-flop with asynchronous reset might look like this. Always at posted CLK or posted reset, begin. If reset, DFF is equal to 0. Else, DFF is equal to DIN. And, in this example, the flip-flop resets to 0 if the reset signal is high. If not, it takes the value of DIN on the rising edge of the clock. From the viewpoint of general computing and emerging technology, the if-else statement in Verilog connects traditional programming concepts with hardware design. It allows engineers to describe complex digital circuits using familiar conditional logic. This makes hardware development more accessible to those with a software background. This approach is especially relevant as the lines between hardware and software continue to blur in areas like field programmable gate, array programming, and custom accelerators. The if-else statement in Verilog is a versatile tool for describing conditional behavior in digital circuits. Its syntax and usage are straightforward for anyone familiar with programming. Yet, it is powerful enough to model a wide range of hardware functionalities, from simple multiplexers to complex state machines. This makes it an essential part of modern hardware description and a key enabler for innovation in computing hardware.